The topic which I have selected is continuous and discontinuous function. After this topic, students will be able to understand continuous and discontinuous function and their graphical representation. We will start this topic from the following two graphs of some functions. Number one is continuous function and the other one is discontinuous function. A function is continuous everywhere in the domain will be a smooth connected curve. So you can see in this graph, this is smooth connected curve. So what about the graph of discontinuous function? In the graph of discontinuous function, we will find gap between the 2 points. These points are disconnected. That's why it is called discontinuous function. One-sided limit. In defining limit f of x when x approaches to c, we restricted x to an open interval containing c. That is, we studied the behavior of f on both sides of c. However, in some cases, it is necessary to investigate one-side limits, the left-hand limit and the right-hand limit. First, we discuss the left-hand limit. Limit of the function f of x when x approaches to c over a negative sign is read as the limit of f of x is equal to L as x approaches to c from the left for all x sufficiently close to c but less than c. The value of f of x can be made as close as we please to c. Now, the right-hand limit. Limit of f of x when x approaches to c over positive sign is equal to m is read as the limit of f of x is equal to m as x approaches to c from the right for all x sufficiently close to c but greater than c. The value of f of x can be made as close as we please to m. Criterion for existence of limit of function. Limit of the function f of x when x approaches to c exists if the left-hand limit is equal to the right-hand limit. We already discussed the left-hand limit is limit of f of x when x approaches to c over negative sign, and the right-hand limit is limit of the function f of x when x approaches to c over the positive sign. If they have same answer L, then the limit of the function exists. There is an example relating to existence of limit of function. Determine whether limit of the function f of x when x approaches to 2 exists. When f of x is, it is called piecewise function. Here, three functions are given with three different conditions. F of x is 2x plus 1 if x is less than or equals to 2, greater than or equals to 0. F of x equals to 7 minus x if x is greater than or equals to 2 and less than or equals to 4. And f of x is equal to x if x is greater than or equals to 4, less than equals to 6. First, we find the left-hand limit. The limit of the function f of x when x approaches to 2 over a negative sign, it means x is less than 2. X is less than 2, so we go to the function. F of x when x approaches to 2 less than 2, you have to see where is x less than 2. Opposite that x less than 2, the function is 2x plus 1. So we put the function 2x plus 1. After substituting the value of x in it, we have the left-hand limit 5. Now we find the right-hand limit. Limit of the function f of x when x approaches to 2 over a positive sign, which means x is greater than 2. Now we choose where is the function where x is greater than 2? Here, x greater than 2, the function is 7 minus x. Now we substitute the value of x2 in it, and we have the same value 5. So here we see the left-hand value and the right-hand value are the same. The limit of the function exists and equals to 5. Now, continuity of a function at a number. First, we discuss continuous function. A function f is said to be continuous at a number c if and only if the following three conditions are satisfied. Condition number 1, the function should be defined at x is equal to c, which is called f of c is defined. Number 2, the limit of the function exists. It means the left-hand limit is equal to the right-hand limit. Number 3, the existence value must equals to the defined value. If these three conditions are satisfied, then we say that the function is continuous function. Now we discuss discontinuous function. If one or more of these three conditions fail to hold at C, then the function f is said to be discontinuous at x is equal to C. Now test continuity and discontinuity. First, you can see in graph, there is a break. At that point, there is a break. So we noted from graph, there is a break. At x is equal to 3. It means the function is not defined. When function is not defined, that is the function is discontinuous at x is equal to 3. Test continuity and discontinuity. We see an example related to this. Discuss continuity of f at 3 when f of x is equal to x minus 1 if x is less than 3, and f of x equals to 2x plus 1 if x is greater than or equals to 3. That type of function is called piecewise function. So first, see at graph. So there is disconnected curve. So there is again there is a gap between these 2 points. So that's why it is called discontinuity. So from graph, we see that the curve is discontinuous. Mathematically, we will prove it. First, we check the function is defined or not, which is condition number 1. Now, f of 3 is equals to 7. Defined value is 7. Condition number 1 is satisfied. Now we find the left-hand limit and the right-hand limit. As you see, the left-hand limit is 2 and the right-hand limit is equal to 7. So both answers are not equal. Limit of f of x is not equals to limit of f of x when x approaches to 3 over a negative sign and over positive sign, which shows that left-hand limit is not equals to right-hand limit. Condition number 2 is not satisfied here. Hence, the limit of the function does not exist. So function is not continuous at x is equal to 3. So here few questions SLO based related to continuity are given. Students can solve very easily. Thank you so much.